sketch the function f of x is equal to x divided by x squared minus x minus 6. First thing we need to find is the horizontal asymptote and the vertical asymptote. When the highest power down is bigger than the highest power on top, horizontal asymptote will always be at y is equal to 0. To find the vertical asymptote, you simply equate the denominator to 0, that is x squared minus x minus 6, equate that to 0. So the product here is negative 6, the sum is negative 1. What numbers can we multiply to get negative 6? If we add them, we get negative 1. That should be a negative 3 and a positive 2. So those two factors. Then that means that this is going to be x minus 3 and x plus 2 equated to 0. And that gives us x being equal to positive 3 or x being equal to negative 1. Now, another thing that I'm going to be able to do is I'm going to now equate everything to 0. So equate what is on top to 0, the x. We are going to have x is equal to 0. Equate the denominator to 0. We have already found that x is equal to 3 and also x is equal to negative 1. And then I'll get all of these values. I'll make a table to see how the function is going to be behaving in these different regions. Smallest value we have here is negative 1 followed by 0 and then 3. These are values of x we've calculated. The one on top we equated to 0 is x, and then we also equated to 0 x minus 3. We also equated to 0 x plus 1. I'm interested in the product of the signs which I'm going to get, because these factors, when we factorize this, the factors we are multiplying. So when I equated x to 0, I found 0. If I use any value of x greater than 0, I put where there is x, it will be positive, and we know that. And then below 0 is this going to be negative. When I equated x minus 3 to 0, I found positive 3. Any value above 3, I put in the factor x minus 3 is going to be positive, and then below it will be negative. When I equated x plus 1 to 0, I found negative 1. Anything above negative 1, for example, is 0, is going to be positive in that factor. And then anything below is going to be negative. If I multiply these three negatives, negative here, positive there, negative here, positive. Okay, and then I'm now able to sketch my function. So what have we been given? Let's put our asymptotes on this graph. We have got positive 3, which is going to be somewhere here. This is an asymptote, so I'll just put dotted lines there. And asymptotes are never touched, especially the vertical ones. For the horizontal, you can touch them unless when you are going towards infinity. And then you have got the other asymptote is negative 1. And then the other asymptote we know is supposed to be y is equal to 0. That is basically the x-axis. Now from when we equated the numerator to 0, we found also a 0. So let me just put a 0 there. 0 is here. Okay. So we can go on now sketching. For the values of x smaller than negative 1, the function is supposed to be negative. Negative means below the vertical asymptote. This is the vertical asymptote. We are going to be below that. So we always follow these asymptotes. We follow the vertical asymptote, and then we follow we follow the horizontal asymptote. This is the horizontal asymptote, and then we also follow the vertical asymptote here. Okay, because the function is supposed to be negative, so we can't go like that. So then we'll just connect these like that. And then between negative 1 and 0, the function is supposed to be positive. Between negative 1 and 0. So this is from this point up to here. The function is supposed to be positive. Then how is it going to go? We'll move from 0 here. We'll go on and follow this function. Follow the asymptote. We don't touch this asymptote. So just follow it like that. And we know when x is equal to 0, what will be the y value? I put 0 here. I put 0 here. I put 0 here. The y value also be 0. That is why I have put it at 0, comma 0 at this point. And then between 0 and positive 3, the function is supposed to be negative, meaning that it's supposed to be below the horizontal asymptote. So it's supposed to drop like this. We follow this other asymptote going down. And then above 3, the function is supposed to be positive, meaning it's supposed to be up like that. Now the question might be, if y is equal to 0 is an asymptote, why is it that we have cut it at this point? Well, for the horizontal asymptote, you don't cut it as you go towards infinity. So you don't cut it as you go towards infinity. On the middle here, horizontal asymptote can be cut. So what will be the domain and the range of this function? So the domain is of this function, smallest x value we can have is negative infinity, and then we are going to go to negative 1. From negative 1, we are going to pause at 3, and then from 3, we are going to go to infinity. And then the range of this function, all values of y are going to be true, or I can write this as from negative infinity to positive infinity. You can see there is no y value that we are not touching. We are touching basically everything.